All right, so to better understand Kroger-Vink notation, I think it's helpful to go through some examples. And so we're going to look at sodium chloride as kind of just an example material. And it's important to relate all of these defects reactions that we, or sorry, these defects that we talk about, relate them to a perfect crystal. So we look at a perfect crystal of sodium chloride, and then we want to describe defects that can happen to those perfect crystals. So let's go with our first example, example 1. Let's see if we can describe a vacancy on the sodium sublattice. So we have species as the main thing, and we talked about how vacancy is a V. It's not vanadium, right? So we have a V as our species of vacancy. And then position is the subscript, and we've been told that it's sodium, so we put sodium. We don't have to worry about the charge, and we don't put the charge because the charge is accounted for in the superscript. So the superscript then is the charge that's left relative to the perfect crystal. So we know that this is a plus charge, right? So if I always start with the perfect crystal, which would have the 0 charge, and then we're getting rid of the charge here, right? So we're subtracting the +1 charge of sodium ion because we're eliminating that to get our vacancy, right? So that gives us a -1 charge. So a vacancy of sodium would have a -1 charge based on our very quick math here, right? And so if we go back to what the negative was, we see that a negative is represented by a dash. So we represent that by 1 dash because it's a -1 charge. So 1 dash, that means 1 negative charge. So this is how we would describe the vacancy on a sodium sublattice. So I always like to do this kind of math with the 0 representing a perfect crystal, and then additions and the subtractions based on the defect with this kind of quick math just to keep track of everything. And so I highly recommend that. All right, so let's look at a second example of a vacancy in this material. So a vacancy on the chloride sublattice. All right, so it's still a vacancy, so it's still V, but in this case, it's on the chlorine. So we're going to put that there. And then again, charge here, and I'll do it even though it seems cumbersome for such a simple problem. I'll just keep doing this. So 0 is our perfect crystal. Then we're going to subtract something by having a vacancy. And we're subtracting a -1 charge based on what's here, right? So in this case, this would be +1. So the removal of a chlorine, negatively charged, leaves us with a +1 charge associated with our crystal, right? So, and in this case, it's +1. So we had a dash for the negative. So we have a dot or a point for positive, and it's only 1 because we have a +1. So again, I just like to do this on each case, go through the charge, put everything in its correct position, and just keep track of everything to make sure that I don't mess anything up.